Have you ever wondered why time seems to fly when you're having fun, but drags when you're bored? This question, while seemingly philosophical, actually has roots in a fascinating scientific concept known as time dilation. Time, as it turns out, may be more of a relative concept than we typically consider in our day-to-day lives. Now, let's dive a little deeper. Time dilation isn't just a metaphorical or emotional idea. It's a scientific one, grounded in physics. It refers to a difference in elapsed time as measured by two observers. The intriguing part is that this difference is due to a relative velocity between them, or a difference in gravitational potential at their locations. This concept might sound like something out of a science fiction novel, but it's a fundamental part of Einstein's theory of relativity. So, does time actually change based on where we are and how fast we're moving? According to Einstein's theory of relativity, it does. Now imagine two twins. One stays on Earth, while the other ventures out into space at high speeds. This scenario is the basis of the classic twin paradox thought experiment, often used to illustrate the concept of time dilation. As our adventurous twin soars through the cosmos at speeds close to light, time for him slows down compared to his siblings' time back on Earth. When he finally returns home, he'll find he's aged less than his Earthbound twin. Sounds like science fiction, doesn't it? But it's actually a consequence of Einstein's theory of relativity. Time dilation occurs in two ways: gravitational and velocity. Gravitational time dilation is the effect of time passing at different rates in regions of different gravitational potential. In other words, the closer you are to a massive object, like a planet or a star, the slower time moves for you. On the other hand, velocity time dilation occurs because of relative velocity between two observers. The faster you're moving compared to another observer, the slower your clock appears to tick from their perspective. So, our spacefaring twin, moving at a high speed relative to his earthly brother, experiences time at a slower rate. In essence, the faster you move, or the stronger the gravity you experience, the slower time moves for you compared to someone else. So what does all of this mean for us in practical terms? Well, let's start with a real-world application: GPS satellites. These satellites are constantly moving at high speeds relative to us on the ground, and they're also further from the Earth's gravitational pull. Both of these factors mean that time actually runs slightly faster for these satellites than for us. To maintain accuracy, the onboard clocks on these satellites have to be adjusted to account for this time dilation effect. If we didn't account for it, GPS coordinates could be off by several kilometers. Now, let's take a leap into the realm of the theoretical: time travel. If we could move at speeds close to the speed of light, or exist in a strong gravitational field, we could experience time dilation to such an extent that we might travel into the future. However, achieving such speeds or finding such a gravitational field is currently beyond our technological capabilities. Furthermore, the energy requirements for such a journey would be colossal, presenting another formidable challenge. But who knows? Maybe one day we'll overcome these hurdles and time travel will leap from the pages of science fiction into reality. While time dilation might not affect our daily lives, it's a fascinating concept that challenges our understanding of time and space and opens up intriguing possibilities for the future.